All right, we're working on quartiles, and so let's get to it. What are the quartiles of a distribution? How do you find them? The quartiles divide the distribution in the quarters. So you might have some data, and you split the quartiles into the quartiles are these four pieces. And so this is Q1, this is Q2, and this is Q3. And so you have the minimum value of your data and the maximum value of your data. So Q2 is what we usually call the median. Okay, and Q1 is the median of the middle and Q2, and Q3 is the median of Q2 up to the maximum. So the quartiles are values that divide the data distribution into quarters. How do we find them? The lower quartile is the median of the data values in the lower half of the data set. The middle quartile is the overall median, this. The upper quartile is the median of the data values in the upper half, right? So Q3 is in the middle of the upper half of the data. Q1 is in the middle of the lower half. The final number summary is exactly what I listed up here a few seconds ago. It's the minimum number, Q1, the median, Q3, and the maximum. The low value, the lower quartile, Q1, the median, the upper quartile, and the high value. To use a box plot, you would do something like this. Where this is the minimum, this is Q1, this is the median, this is Q3, and this is the max. Draw a number line that spans all the values of the data set and close the values from the lower to upper quartile in a box. That's why it's called a box plot. I'm sorry, so it's A. Draw a number line that spans all the values in the dataset and close the values from the lower to the upper quartile in the box. Draw a vertical line through the box at the median at whiskers extending to the low and high values. That one is A. Decide whether the following statement makes sense or does not make sense. Both exams had the same range, so they must have had the same median. No, that's not true, because here's an example: 1, 2, 3, 4, 5, 6, right? So the median here, 1, 2, 3, 4, 6. The range here is the difference between the high and the low values. The range is 5. So the range is the difference between the high and low values. The median here is 3, but I could do 1, 2, 5, 5.1, and 6. And here the range is still 5, but the median is very different. This does not make sense because the range is the difference between the highest and lowest values. It has nothing to do with the median. The median can be whatever it wants. It has nothing to do with the range. Decide whether the following statement makes sense or not. The standard deviation for the heights of a group of 5-year-old children is smaller than the standard deviation for the height of a group of children who range from 3 to 15. And so the standard deviation is a measure of how much the data varies from individual to individual. So when you have a group of 5-year-old children, their heights are not going to be that far from each other. But when you have children ranging from 3 to 15 years of age, then their heights are going to vary a lot more than just 5-year-old children. And so that standard deviation will be higher for those people. The statement makes sense because the range of data for the heights of a group of 5-year-old children is smaller than the range for the heights of a group of children who range in the age of 3 to 15. Let's do some data analysis. Find the mean and median for the waiting times at Big Bank given below. Show your work clearly and verify that they're both the same. All right, are these in order? They look like they are, so we can get the median immediately. So how many times are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 values. The median is the middle number, 1, 2, 3, 4, 5, 6. The median is 7.2. We'll go through this carefully, but we have the median is, the median is the 6th value, and because this is an odd number, so it's A, so it's a 6th value. The median is 7.2, and apparently these are supposed to be equal, so let's add up all these values. Right, so the mean is the sum of all the values divided by the total number of values. We knew that. Let's add these things up. So we're talking about 4.1 plus 5.2 plus 5.6 plus 6.2 plus 6.7 plus 7.2 plus 7.7 plus 7.7 plus 8.5 plus 9.3 plus 11 is that. Then we're going to divide by, I believe there are 11 numbers, and the sum of all the values, let's get this back. We need the sum of all the values. It was 79.2. The total number of values is 11, and so the mean is 7.2 when you divide. And so the mean is equal to the median. After recording the pizza delivery times for 2 different pizza shops, you conclude that one pizza shop has a mean delivery of 44 minutes with a standard deviation of 4 minutes. So it varies on average 4 minutes. The other shop has a mean delivery of 43 minutes with a standard deviation of 20 minutes. So that's a larger variation. So this, the average is 43. They're big swings. So this means that sometimes it could take an hour, sometimes it could take 20 minutes. Interpret these figures. If you like the pizzas from both shops equally, which one would you order from? So we will order from this one because it's more reliable. It's 44 minutes plus or minus roughly 4 minutes or so, right? The means are nearly equal, but the variation is significantly greater for the second shop than the first. That's a fact. If you like pizza from both shops equally, which one would you order from? Why? Choose the correct answer below. We're going with the first shop. Delivery time is more reliable because it has a lower standard deviation. There's less variance. Each night you total the day's sales and the total volume of ice cream sold in your shop. You notice that when an employee named Ben works, the mean price of the ice cream sold is $2.50 per pint with a standard deviation of 30 cents. On nights when an employee named Jerry works, the mean price of the ice cream sold is $2.20 with a standard deviation of 5 cents. Which employee likely receives more complaints that his servings are too small? All right, so the means are nearly equal. So we're talking about Ben's standard deviation is larger. He likely serves the smaller portions. 8. The lowest score in an exam is 68, the median is 76, and the high score is 92. What's the range? The range is the highest value minus the lowest value. The range is 24 because that is the difference between the lowest score and the highest score. The lower quartile for wages at a coffee shop is 8.75 and the upper quartile is 10.25. What can you conclude? Well, if the lower, so if 8.75 is here, right, and this is 25%, this is the lower 25%, and then $10.25 is here, and this is the upper 25%, and that means that the middle 50% is in between. Half the workers earn between $8.75 and $10.25. Which data set would you expect to have the highest standard deviation? Heights of newborn infants, all right, they should be bunched together. So they shouldn't vary that much, so they shouldn't deviate from the average that much. Heights of all elementary school children, okay, that looks like that's going to be pretty big. Or first grade boys. Well, elementary school children, that ranges from 1st to 6th grade, so that could have a high variance in the heights, and the range would be high. The heights of all elementary school children, since it has the largest range. Hope it helps.